Hello students, most welcome to Dr. Acharya Academy. Today I am going to discuss Lewis representation of simple molecules, that means the Lewis structure. In the previous class, you already understand that what is the Lewis structure and how to represent in a very simplified way. Now, in this class, we'll discuss details about the Lewis structure. Today's class number is 068. The Lewis dot structures provide a picture of bonding in molecules. In the previous class, also I discussed about this. And ions in terms of the shared pairs of electrons and the octet rule. While such a picture may not explain the bonding and behavior of the molecule completely, but it will help to understand the formation and properties of a molecule to a large extent. Therefore, the writing of Lewis dot structures of molecules is very useful. The Lewis dot structure, how to write? It have some steps. Step number 1, the total number of electrons required for writing the structure are obtained by adding the valence electrons of the combining atoms. Example, suppose one molecule CH4. So CH4 means 1 carbon atom and 4 hydrogen atom. We know that carbon atom, it has valence electron 4 and each hydrogen atom has valence electron 1. So 4 hydrogen atoms has 4 electrons. So total number of electrons in this methane molecule, CH4 molecule, how much? Yes, 8 valence electrons. 4 from carbon atoms and 4 number of electrons from 4 number of hydrogen atoms. Now step number 2, for anions. Each negative charge would mean addition of 1 electron. See example, carbonate ions CO3 2 minus. 2 minus means the 2 negative charge, and it indicates that there are 2 additional electrons than those provided by the neutral atoms. That means if it is CO3, that means 1 carbon and 3 number of oxygen. And for its neutral atoms, whatever electrons they have, valence electron, you have to add 2 number of electrons, because 2 minus means 2 negative charge. And for cations, each positive charge would result in subtraction of 1 electron from the total number of valence electrons. We know from the previous class that positive charge formed by donating 1 electron to other atoms. So example, NH4 plus. So whatever the total number of valence electrons for NH4 as a group of neutral atoms, you have to subtract 1 electron to get the total electrons, valence electrons for NH4 2 minus ion. Step number 3. Knowing the chemical symbols of the combining atoms and having knowledge of the skeleton structure of the compound, it is easy to distribute the total number of electrons as bonding shared paired between the atoms in proportion to the total bonds. So, in general, the least electronegative atom occupies the central position in the molecule or ion. Example, you consider NF3. NF3 and for the carbon atom CO3 2-. This case for NF3 nitrogen and CO3 2- for this is carbon are the central atoms. Why? Because in these two molecules and ions, CO3 2- it is ion and NF3 it is the molecule. For this the least negative atom, which one? Nitrogen is the least negative in NF3 molecules and carbon is the least electronegative compared to the oxygen. So that's why that nitrogen and carbon is the central atoms for NF3 and CO3 2- ions respectively. And in this case, the fluorine comparatively electronegative, more electronegative, and oxygen also comparatively more electronegative. In CO3 2-, they will occupy the terminal positions. Number 5. After accounting for the shared pairs of electron for single bonds, we know that one pair of electrons is there. The remaining electron pairs are either utilized for multiple bonding or remain as lone pairs. So the basic requirement being that each bonded atom gets an octet of electrons, except for the hydrogen. Hydrogen here is gender. Each hydrogen atom attains the configuration of helium. That means a duplet of electrons. Other atoms will get the octet of electrons. So here is some example regarding the Lewis representation for some molecules. You can see, and these all you can write also whatever the rules just now I discussed. On that basis, you can write all this Lewis structure by using this molecule or ions. Maybe it will be your home task. So here is some problem. Write the Lewis dot structure of CO molecule. So first you have to count the total number of valence electrons of carbon and oxygen atoms. So carbons, what is the electronic configuration of the outer shell? 2s2, 2p2. And for oxygen, what is the outer shell's electronic configuration? 2s2, 2p4. So number of valence electron 2 plus 2, 4 for carbon atom, and this 2 plus 4, that means 6 electrons for the oxygen atom. So total number of valence electrons for CO molecules is 4 plus 6 is equal to 10. What is the step number 2? Step number 2, the skeleton of structure of CO is written as C gap O. Now step number 3, draw a single bond, that means one shared electron pair between the carbon and oxygen and complete the octet on O. And then you can see this is the individual atoms, carbon and oxygen. This is the Lewis structure, and for the molecule, you have to write the Lewis structure. Then between carbon and oxygen, you have to put one single bond which represents the 2 electrons, and then you have to complete the oxygen octet form. How much? 1, 2, 3, 4, 5, 6, and this pair of electron also shared by the oxygen, so it is the total number of 8 electrons to form the octet for the oxygen atoms. And these 2 electrons are the lone pair on the C. These 2 electrons is there. This is the lone pair of C. So this does not complete the octet ion on the carbon, because you carbon C 1, 2, 3, 4. And hence we have to resort to multiple bonding. That means we have to put multiple bonding to get the octet formation of this. So how it will happen? That how much short? 1, 2, 3, 4. So another 4 number you have to add here. So 4 number means 2 pair of electrons. 2 pair of electrons means each pair of electron means 1 bond. So 2 pair of electrons means 2 bonds and 1 single bond already there. So you have to form ultimately triple bond. If you form the triple bond, then you see that for carbon both is full the octet. That means 1, 2, 3, 4, 5, 6, 7, 8. And for oxygen also octet formation happens. 1, 2, 3, 4, 5, 6, 7, 8. And then the final structure is the one lone pair on carbon, then triple bond, then oxygen atoms, and oxygen atom has a lone pair of electrons according to step number 4. I hope that you understand this molecules Lewis structure, and it will be very helpful for your understanding the Lewis structure, the chemical bonding. Thank you so much for watching this class.